let's move to the second part of this. This is about curvilinear motion. So what about curvilinear motion using rectangular components? We know, guys, that not all the motions are rectilinear. So we still have a curved motion, a curvilinear motion. In this case, when I have a curvilinear motion, I should not use the knowledge acquired in the rectilinear motion, because in fact here I have a curve. Now in this part, I'm gonna represent this curve using rectangular components. Now what are the rectangular components? They are x, y, z. Vector, they are I, j, k. So I should, for example, represent the vector position R using x, I plus y, j plus z, k. And then V will be the derivative. It's also a vector, and it will be the derivative, so that Vx will be the derivative of x with respect to time. Vy will be the derivative of y with respect to time, and Vz will be the derivative of z with respect to time. And this is applied to that acceleration. And what you should know here, guys, that S here in the curvilinear motion belongs to the path. It has the same direction of the path, which means S now is different than the algebraic value of R, like in the rectilinear motion. Here, guys, delta R has the algebraic value of delta S, all right? It's not R itself, all right? So guys, this is S here, and if I take this origin, this is R. I know that delta R is R prime minus R, so this will be delta R, all right? Now, the algebraic value of delta R will be the displacement. But R, the algebraic value of R will never be here in curvilinear motion, S, all right? It's not S here in curvilinear motion. So guys, this is a very easy part, in fact, because it's all about doing the integration or doing the derivation by taking into account the boundary condition. So let's start with this very easy example, example 6.69 in the textbook. The velocity of a particle is given by v is equal to 16t squared I plus 4t cubic j plus 5t plus 2k, where t is in seconds if the particle is at the origin when t is equal to 0. What does this mean? Who can tell me, guys? What does this mean? If the particle is at origin when t is equal to 0, what does this mean, guys? Abbas is saying s is equal to 0 at t is equal to 0. This is not right, Abbas. Hassan is saying that r is equal to 0. You're right, Hassan. R in vector form is equal to 0. So this means in curvilinear motion, guys, that R in vector form is equal to 0. And this implies what? If R in vector form is equal to 0 at t is equal to 0, this implies what, guys? Quickly. What about x, y, z? If the vector is equal to 0, then all the components of this vector should be equal to 0. X is equal to 0, and t is equal to 0. And this is a very important note, guys, all right? I cannot solve the problem unless I know x, y, and z. Y is equal to 0, and z is equal to 0, and t is equal to 0. Right? So I'm going to call this R0 so that you know that this is at t is equal to 0, y0, x0, and z0. Determine the magnitude of the particle's acceleration when t is equal to 2 seconds. So I need to find what is a when t is equal to 2 seconds. And I know that what is a, guys? A in vector form is equal to the v in vector form over the t, right? And this means, guys, that what is ax? Ax is the derivative of vx, right? Now I know that vx is 16t squared, right? So what will be ax? It is 32t. What about ay? Ay is also the derivative of vy. Now vy is 40 cubic, then this means that this is 12t squared. And what about az? So this is a 3D motion, in fact. What about az? Would be equal to 5 only. All right, because vz is 5t plus 2. All right, guys. Now the question is to find this acceleration when t is equal to 2. which means 2 seconds. In this case, AX will be equal to 32 times 2. I did it in fact using MATLAB. I defined T2, AX, Y, Z by the equation. Okay, so and guys, now you're seeing my slides. All right. So guys, I know AX, AY, AZ by substituting T by 2 seconds so that I can find A. Well, what is A? A is in fact the radical of the sum of the square of my components. All right. So don't forget, guys, this is the magnitude of A. All right. So I did it using MATLAB, and A, which is the square root of AX squared plus AY squared plus AZ squared, is 80. 80, of course, what is the unit of A? It is meter per second squared. All right. Now this is the first part of the question. The second part is what are X, Y, Z, or what is the X, Y, Z coordinate position of the particle at this instant, which is T is equal to 2 seconds. And this is a very important part because I'm going to use now the boundary conditions, which is R0 is equal to 0 when T is equal to 0. All right. So I'm going to find, in fact, R, which is X, Y, Z, since I know V. Now, what is R? I know, guys, that V is equal to what? To dr over dt in vector form. Right. The question is, what makes AZ constant? I don't know. In fact, I don't know what is the type of this motion, right? So, in fact, I know VZ, it's 5t plus 2, so that AZ will be 5. I don't know the type. I don't know the forces exerted on this motion. So here I'm concerned about kinematics and not kinetics. So that's why I don't know the forces, right? I'm not interested at all now, for the time being, right? Now in kinetics, I should find out what are the forces, and then I can find the acceleration. From acceleration, I can find V and then R. All right, so V is equal to dr over dt, and this means, guys, that the integration of dr that I need to find is equal to the integration of V dt. What are the boundary conditions here? Because I have an integration. In fact, guys, when t is equal to 0, r is equal to 0. All right, and this is from the boundary condition given in the question. Then this is V, and then this is R. And I know that R in vector form is X, Y, Z. So it is Xi plus Yj plus Zk, right? So it is X, Y, Z. So if I need to find X, I should do the integration of this V. Now, what is the integration of this V? It is 16 T3 over 3, all right? So it is 16 T3 over 3, this X. Right, so guys, I'm gonna say that this will imply, and then I'm gonna say that this is X. And now what is Y? Y is the integration of Vy, and I know that Vy is 4t cubic, right? So since this is a 4t cubic, then this is a 12, so this will be 44 over 4, which is T4, right? So this is T4. And what about Z? Now I know that Z is 5t plus 2 Vz, so I can find Z by 5t squared over 2 plus 2t, right? Sorry. So 5 t squared over 2 plus what? Plus 4. Right? And then, guys, I can replace t by 2, and now if I replace t by 2, this will be 16 times 8 over 3. I think this will be 46, around 46, and then this will be 16, and this would be 40. Right? So this is when r is equal to 0. I'm gonna now do the same, but what if, and quickly, guys, because we don't have a lot of time, what if r in bold, which means r is a vector, all right, is not equal to 0 when t is equal to 0. So it's not 0 when 0. So let's assume, guys, that, for example, r is equal to I minus k plus, minus j plus 2k. What do you think will happen? So guys, I'm gonna do the same. I'm gonna do the integration. However, now dr is not between 0 and r. It is between, in fact, r0 and r, and this will be equal to the integration of v in vector form dt. All right, and then t will be 0, between 0 and t. So guys, now I have a certain r0, and this means, guys, that r minus r0 will be equal to the integration of v. And what is the integration of v? In fact, this is the integration of v. All right, so it is 16t cubic over 3 t4 and 5t squared. So it will be 15 t cubic over 4 t cubic, t4 and 5 over 2 t squared plus 2t. Okay, guys. So what should I do now? What will be my x? And this means, guys, that x will be equal to this answer here, which is 46. I'm gonna take this r0 after the equal sign, and this will be plus x0. What is x0? x0 is 1. So this is 46 plus 1. And what about y? This is x. And what about y? Y will be equal to t4 when t is equal to 2, which is 16, plus y0, which is minus 1. So it is 16 minus 1. And then z will be, guys, the answer of this one, which is 14, plus z0, which is 2. All right, guys? You're right. This is over 3. I'm sorry, Hassan. This is over 3. Okay? So, guys, did you understand what I did here? In this case, I don't have r0 as t when t is equal to 0. What I have here, r is not equal to 0 when t is equal to 0. And this means, guys, that in order to find x, y, z, I should add x0. So I should take this after the equal sign and add x0. Now here, since r0 is I minus j plus 2k, then x0 will be 1. y0 will be minus 1, and z0 will be 2. Right? So I have to add them into the answer in order to find x, y. Right? Do you have any questions so far, guys? Quickly. I still have the most of the project hard. Okay. Right. Okay, we still have this problem, guys, but it's very easy. You can solve it by yourself because, in fact, I know the equation of V, and I need to find the displacement of the particle between t is equal to 1 and t is equal to 3. And don't forget, guys, that the integration of the dr now should be the integration of v dt, but between 1 and 3. All right? So I have to find dr. Now I don't have to put the boundaries here because, in fact, I should find delta r. I should find delta s. All right? So I'm going to find delta s, or the displacement, or delta r in algebraic value, by doing the integration of v dt between 3 and 1. All right? So I should do the integration of a 3, which is 3t, and then this t should be between 3 and 1. This is a 2D case, so I don't have that. I only have x and y, or I and j. And then the second one is 6t. Now this is delta r, in fact, because I'm doing it as a vector. So it is 6t minus 2t squared over 2 between 3 and 1. Right? So guys, you're going to find this answer, and you're going to find this answer, right? And whenever you know delta r, you can find the magnitude of delta r, which is here, the displacement. So guys, it's not hard to do this by yourself. You can do it. It's very easy. And let's move to the third part of this session, which is the part of project art. All right.